In the previous lecture, we noticed that the distribution of returns took on a shape that looks like a bell curve. Whenever you see a bell curve, you should automatically think about the normal distribution, also called the Gaussian distribution if you are not from statistics. In this lecture, we are going to start discussing different ways that we can check if the data that we have sampled actually comes from the normal distribution. This lecture will look at a visual method of checking this, called the QQ plot, short for quantile-quantile plot. So what is a quantile-quantile plot? Well, first, we should probably review what a quantile is. If you're not a student of statistics, it's probably a strange word. Basically, you can think of quantile as something like the inverse of the CDF. Remember, this is just intuition, so nothing I'm saying right now is meant to be precise. As you recall, the CDF, which stands for Cumulative Distribution Function, tells you the probability that the random variable is less than the value that you pass in. So for example, suppose I'm measuring the heights of students in our classroom. I have a CDF function and I pass in the value 6 feet. If I get back the value 95%, that means 95% of the class is less than 6 feet tall. The percentile, which is a kind of quantile, is basically the opposite of that. I can input 95% and I get an answer in feet. For example, I can ask, how tall do I have to be so that I am in the 95th percentile? That's equivalent to asking, how tall do I have to be so that 95% of the class is shorter than me? And the answer is, of course, 6 feet. Quantiles are a generalization of percentiles. For percentiles, we have 100 buckets, so we can ask, how tall do you have to be in the 95th percentile or the 96th percentile, and so on. Quantiles can be broken up into any number of bins. So for example, if we have 4 bins, we call them quartiles. Anyway, this is not so important for understanding QQ plots. I just want to give you a basic idea of what the word quantile means. So what is a quantile-quantile plot? A quantile-quantile plot is a plot where on one axis, we plot the sample quantiles, and on the other axis, we plot the theoretical quantiles from the distribution that we think our data was sampled from. The basic idea is, if the data really did come from this theoretical distribution, then the points on the QQ plot should be nearly a straight line. So the interpretation of a QQ plot is pretty simple. If you see a straight line, that's generally a good thing. That means your data really did come from the distribution you thought it did. If you don't see a straight line, that's generally not a good thing. That means the distribution you tried to match your data to is probably not a good fit. By the way, note that another name for this kind of plot is the probability plot. So if you see a function called probability plot, it probably refers to the same thing as the QQ plot. We often speak of the normal probability plot, which is a probability plot or a QQ plot where the theoretical distribution is the normal. Let's look at what would happen if your data does not fit the theoretical distribution. Here's a common scenario in finance where your data is more fat-tailed than the normal. That means your returns are more extreme than what would be predicted by the normal distribution. We know this to be true because sometimes the stock market crashes, or sometimes things go up in value very quickly, such as cryptocurrency. The probability of these events under the normal distribution would be infinitesimally small, so we know that normal distributions are probably a poor approximation to real-world returns. In any case, what does a QQ plot look like when we have heavy tails? Well, we see that the points will deviate from the straight line at both ends. Generally speaking, there are only a finite set of patterns you will typically see in a QQ plot when the data doesn't match the theoretical distribution. This happens when the data has heavier tails than the theoretical distribution, or when the data has lighter tails. You see a different pattern when the data is more left-skewed or more right-skewed. Note that, depending on which book you're reading, what you see will depend on whether the theoretical distribution is on the horizontal axis or on the vertical axis. If you switch the axes, then you also have to flip the plots. The plots from this image correspond to samples being on the horizontal axis and the theoretical distribution being on the vertical axis. As an exercise, you might want to generate your own data to demonstrate that these patterns do in fact correspond to these scenarios.